Hello everybody. Welcome to your second lesson on factoring. This is Mr. Kaya speaking. So, what we're going to do today is just go through some much more difficult problems that involve some factoring, and hopefully by the end of today, or at the end of this lesson here, you guys will have a pretty good grasp on what is required of you when it comes to factoring these polynomials. Okay, so the first one we're going to look at is number 1 here. So we're going to start with number 1. So as you can see, there's 4 terms here. Okay, so that being said, I also want to point out that this thing is not in standard form. Okay, as you can see, we go from a degree measure or a degree of 3 to 1 to 2 to 0. And so in order to do this properly, we have to make sure that it is in standard form first. Our degrees go from larger to smaller. So we're going to have to change this one real quick. It's not a big change. I'm going to go 12x cubed minus 21x squared plus 28x minus 49. Okay? So, our first step here, all right, is to see if we can take out a GCF. Now, as I look across these numbers here, you'll notice that you really can't, right? We really can't take out, I mean, if we took out, we could take out a 7 from these, but we can't take anything out from this 12. Okay, so as far as GCF goes, there is no GCF for these 4 terms. Okay, so we're just going to have to go by factor by grouping. Okay, so what we're first going to do is we're going to factor out definitely an x squared. But also, it looks like I can take out at least a 3. So I'm going to take out a 3. That leaves me 4x minus 7. Okay? Now, in order to ensure that this is a factorable problem, all right, and because we're using factor by grouping, all right, when I take out a GCF from this next pair of terms, I want to make sure that I'm left in parentheses that same 4x minus 7. So I see that's a positive 28, so I'm going to take out a 7. I'm going to be left with 4x minus 7. Okay, so as you can see, in both side of parentheses, we're left with the same binomial. And now, we just write out what we have left. So 3x squared plus 7, 4x minus 7. Okay? And I'm just going to verify, can I take anything else out of either one of these pieces? Negatory. So our answer is this right here. Okay, let's look at number 2. Number 2, okay, not really a whole lot going on here. All right? So really, all we have to do is try to simplify this guy. So, I'm going to distribute that negative sign. So I'm going to go x minus 3 minus x plus 5. Okay, so after distributing the negative sign, you can see these are going to cancel, and you're left with the negative 3 and the positive 5, which is 2. Okay, so nothing too exciting going on in that problem. Just be careful about that negative sign. Make sure when you go to add these things, you distribute that negative sign and change your signs. Okay, number 3. All right, now I try to emphasize with students that there's a couple ways you could go about this. Now, if you're looking at it, you're probably like, man, I got to do all this. Gonna distribute that there. Gonna distribute those in there. Okay, and then combine like terms and try to simplify that way. Okay, which isn't the wrong way. All right, you could do it that way, but it's going to take you much longer than the trick I am going to show you. So if you notice, in the left set of terms, the left pair of terms, and the right pair of terms, they both have something in common here. They both have something that's being multiplied in both both parts of this, on both sides of the subtraction sign. And if you look careful enough, you notice that 2x minus 1 is in both sides. So let me go back to this for a second. If I had 5x plus 5y, right, and I say factor this problem, all right, or take out a GCF, okay, you would immediately go take out that 5, be left with x plus y, right? That's factored, okay? These two things multiplied together gets us back to the original, all right? Now, it might not seem so obvious here, okay, but instead of multiplying all that through, why not save ourselves some time and take out a 2x minus 1 from either sides, right? Kind of like if this was 5, this was x minus 5, and this was y, okay? We're just taking out that 5, all right? So in this case, obviously we're not taking out the 5, but I'm just trying to demonstrate that these are still just factors here, okay? These are still just some number. We don't know what x is, but if we were to plug x in there, we would get some number there. Okay, so on both sides, they have a greatest common factor of 2x minus 1, right? That's being multiplied to both sides. So what you do is you take it out, okay, and you're left with, make sure I put this in parentheses now, so it's going to be 2x plus 7 minus x minus 3, okay? Now I know you're thinking, that's a lot of parentheses there. Yeah, it is, but it's also important that you kind of separate what's going on here, okay? So this 2x minus 1 I factored out of both of those pieces. So if I were to distribute it, multiply it back in, it would just go into the front of both of those binomials there, okay? So going back to that, all we have to do now, it's like we did number 2, we're going to combine like terms. So I'm going to go 2x minus 1, that stays in parentheses. I'm going to go 2x plus 7, and then I'm going to distribute that negative sign. So I'm going to go minus x plus 3. And then finally, our last step is to just simplify. So we're going to go 2x minus 1. 2x minus x is just an x, and 7 plus 3 is 10. And that's the answer to number 3. Okay, number 4. All right, so this one's got a little trick to it, okay? Hopefully you recognize you can take out an a from both sides. So you're left with x to the 6 minus 1. And so some of you are thinking, well, what do you mean? Aren't we kind of done here? Wrong, okay? Because this is an example of a dots problem, okay? And so what gives you that strong indication here is take a look at this number right here. Because it is even, can 6 be divided by 2? Absolutely, right? So x to the 6th is really x cubed squared, right? Using our laws of exponents, if I multiplied this in, that would give me x to the 6th. Also, x to the 6th is equal to x cubed times x cubed. So clearly, this is some number being squared, all right? Being multiplied by itself twice. Don't get confused because of that extra 3 in there. Just picture this as some whole number or some number being multiplied by itself twice. It just happens to be some cube number. So, in this case, all right, x to the 6 minus 1 is an example of a dots problem, okay, or a difference of 2 squares. You see the minus sign in between them? We'll just know it's a difference of 2 squares. So we're going to go a, and remember our rule, a squared plus b squared is equal to, or not b, not plus, hold on, difference. So a plus b, a minus b, right? And so in this case, our thing being squared is actually x cubed. So x cubed plus 1, x cubed minus 1. Okay? And again, x cubed squared is x to the 6, right? X cubed times x cubed. Okay, so if it wasn't quite visible for you, take a look at this exponent right here. And if it is divisible by 2, okay, and this is some number that could be squared, don't forget 1 is still a square number, okay, then we have a difference of two squares problem. Okay? So just be aware of that. Take a look at that exponent when you have two numbers here, and if it's divisible by 2, we know that this is a dots problem. Let's go to number 5. Okay, so number 5. All right, we have x to the 6th minus 3x to the 4th minus 40x. Okay, so we're going to take out a GCF, x squared, so that leaves me x to the 4th minus 3x squared minus 40. Okay, notice this is still double. This degree is double the other, so we're good here. We know that this is a factorable problem. All right, what you want to make sure is that this number is double that middle degree here, okay? So because it is, we know it's factorable. Now, we have to look at the factors of negative 40. So we're going to go negative 1 and 40, whoops, negative 5 and 8, negative 10 and 4. Okay, I'm already seeing an answer right here. Okay, which one of these can we add together to get a negative 3? This one right here, but we're going to have to change our signs. Okay? And because we don't have a leading coefficient here greater than 1, we can just go right to the parentheses. All right, so don't forget to split this up. It's going to be x squared plus 5, x squared minus 8. Okay, so anytime you got one that's larger than 2, right, so in this case we got a 4, you just divide that in half. Then we want to make sure, okay, because I see two terms here, right, is this a difference of two squares? Absolutely not. 8 is not one of our perfect squares. So therefore, we are done. Let's go to the next one. Okay, might not seem obvious, all right, we know 16 is one of our perfect squares, but it's 625. If you guys don't know, 625, the square root of 625 is 25. So 16 is just 4 squared. This is just 25 squared. So therefore, and we have a difference here in the middle, which leads me to believe that this is a dots problem. So a squared minus b squared is equal to a plus b, a minus b. Right, so in this case, our a is going to be 4. Don't forget our n, so n squared, right? We're going to just break that in half. So 4n plus 25, and 4n squared minus 25. All right? And this will get you back to the original. These are the factors. 16n to the 4th minus 625. Okay. You keep going here. Got 4 more problems. So number 7. All right. Might not seem obvious again, but this is also a difference of two squares problem. You guys are thinking there's a fraction there. Okay. So let's talk about that fraction. Is that a perfect square? Is that a perfect square? This is actually 6 squared. This is actually 11 squared. So this is still a square number. And if you think about it, right, if we had 6 over 11 and we squared that, we would get 6 squared over 11 squared, which is 36 over 121. Okay, don't forget your rules of exponents. When you square a fraction, you square the top and the bottom. Okay, you're squaring both numbers. So therefore, we have a perfect square. How about x to the 10th? Is it divisible by 2? Sure is. So there's some number squared, and then obviously 36 is just 6 times 6. So we have another difference of two squares problem. So in this case, our a, 6 over 11, and our b, whoops, not 36. It's just 6. And x to the 5th. So, our answer to this is going to be 611 x to the 5th plus 6. 6 over 11 x to the 5th minus 6. And that is our answer to that one. Number 8. Okay, so we're looking at the factors of negative 72. Right, this is double this, so we're good there. Okay, so the factors of negative 72. Okay, we're going to go negative 1 and 72, negative 2 and 36, negative 3 and 24, negative 4 and 18, negative 6 and 12. Okay, and so I'll stop right there because I've just found our solution, right? What two numbers can I add together to get a positive 6? Right there. And I don't even have to change the signs, right? But I do always put that negative sign in the front just to remind myself that I need to keep that. Okay, so because there's no leading coefficient, we don't need to do factor by grouping. Okay, so we're going to go x to the 4th minus 6, x to the 4th plus 12. And that is our answer. Okay, moving down below here. All right, so a lot of times when we're factoring, we really don't like having a negative coefficient. Okay. So, we really don't want to change anything either. So, we're just going to have to work through it. All right, so we're going to take this, we're going to multiply. So, we're going to be negative. Ooh, whoops. Negative 180. Okay? All right, so negative 180, what are the factors of negative 180 that add up to negative 24? Okay, so I'm looking down through here, and one of the factors I see is 6. Well, let me just do them all here. Negative 1, 180, negative 2 and 90, negative 3 and 60, negative 4, 45, negative 5 and 36, negative 6 and 30. I'm going to stop right there because I know that adds up to negative 24. Okay, but I am going to have to switch these signs. That becomes negative. All right, so here's the tricky part here, though. Okay, I'm going to put this x to the cubed here. Okay, I'm going to put, oh, we got a, oops, no, wrong, Mr. Kaya. We have to factor by grouping here. All right, because we've got a leading coefficient greater than 1. Well, it's actually greater than 1, but it's a number that's greater than 1, right? 3 is greater than 1. So we're going to go minus 30x cubed plus 6x cubed plus 60. All right. So we're going to factor by grouping here. All right, so out of this first piece, I'm going to take out a negative number. So I'm going to take out a negative 3. So that's the most I can take out, right? Oh, I'm sorry, and an x cubed. So after taking that out, I'm left with x cubed plus, what is this going to be? 10? No, just 10. Perfect. Then over here, I'm just trying to mimic this last set of parentheses here, so I'm going to go take out a 6 again, so it's going to be x cubed plus 10. And so our final answer is negative 3x cubed plus 6 and x cubed plus 10. So sorry about screwing up on that one a little bit. But anyway, that is the answer to number 9. So we're going to skip number 10. All right, I'm going to cut the video short. All right, and then for the blue group, for the blue group, I want you to do the odd ones. So 1, 3, 5, 7, and 9. And for the red group, I want you to do all the evens, which is 2, 4, 6, 8, and 10. Okay, so that's going to be your assignment. There's the first 9 problems we did. I want you guys to try those on your own. So red's got the evens, blue's got the odds, and so there's your first video lesson. All right. Let me know if you have any questions.